Hello mga kawan and good day future chemist. Welcome to the General Chemistry 1 class. This section is on measurements, focusing on precision and accuracy. In this lesson, we will differentiate between precision and accuracy. Measurement is a process in which numerical values is associated to properties of matter. This involves comparison with a known quantity of the same kind. Measured values, however, can never be as exact as we think. This is because errors in measurement are inevitable. Hence, in dealing with measured data, we need to consider two things: precision and accuracy. Precision and accuracy are terminologies that we might use interchangeably in our daily lives. However, technically speaking, these two words have different meanings. Take note, precision is the agreement between different measurements. One can check for precision of measurements by performing repeated measurements. One measure of precision is deviation. Deviation, or DI, shows how a measured value, or XI, differs from the mean, which is the sum of all measurements divided by the number of measurements. Deviation is the absolute value of a measured value from the mean value, and that means that sign of the difference is ignored. So you have here the summation, or the mean value, is equal to the summation of the measurement over divided by the number of measurements. Another measure of precision is the average deviation. The average deviation is obtained by determining the sum of all deviation divided by the number of measurements. Lack of precision of measurements is caused by random errors, or errors arising from the unpredictable changes in measurements. Such as errors are usually caused by human errors. An example is different volume readings of a liquid in a graduated cylinder, maybe several experimenters. Let us have a sample problem. Two different rules were used to measure a pencil. Measurements are shown on the right. Which of these rules provide the precise measurement? What is your answer? In ruler number 1, you have 18.1 centimeters, 18.2 centimeters, 18.3 centimeters, 18.3 centimeters, and 18.2 centimeters. While on the other hand, for the ruler number 2, you have 18.22, 18.23, 18.21, 18.23, and 18.22 centimeters. So for ruler 1, calculate the mean of all measurements. So you have the mean, or the sum, is equal to the summation. The summation of all the measurements. You have 18.1 centimeters plus 18.2 centimeters plus 18.3 centimeters plus 18.3 centimeters plus 18.2 centimeters. And divide all by the number of measurements. So you have 1, 2, 3, 4, 5. So divide by 5. So add all the measurements. So you have 19.1 centimeters. And you have the number of measurements, 5. Do the operation. And you have there 18.2 centimeters. and 18.2 centimeters will be the mean for the measurement using the ruler 1. Next step is to get the deviation of each measurement from the mean. Get the difference of each measured value and the mean, ignoring the sign of the answer, as seen on the second column. So using the formula, you have the deviation is equal to, the initial minus the mean. So you have 18.1 minus 18.2. So as you can see, here the 18.2 is constant because that is your mean. So as you can see, you have there the result. 0.1 centimeter, 0 centimeter, 0.1 centimeter, 0.1 centimeter, and 0 centimeter. Now, get the sum of all deviation. So you have 0.3 centimeters. So get the sum of all the deviation and simply get the sum of all the values in the second column, obtaining a value of 0.3 centimeters. Next is calculate the average deviation. So you have there, divide the sum of the number of observation, in this case 0.3 centimeters by 5, then we get 0.06 centimeters, the average deviation for the measurement using the ruler 1. Now let us proceed to the processing the second set of data. We first get the mean of the values. Considering the given solution, we get the mean to be 18.22 centimeters. So again, just use the formula and again add all the measurements and divide by the number of measurements. You have 5, so do the operation. So you have 91.11 centimeters over 5 and divide all, you have 18.22 centimeters. Now the next step is to get the deviation of each measurement from the mean, which is 18.22 centimeters. The solution are shown on the second column. So as you can see here, so you have 18.22. As you can see, they are stagnant or they are constant because those are the mean. So as you can see, you have now the deviation. And now the next step is, afterwards, get the sum of these deviations. And the sum of deviation is 0.03 centimeters. So lastly, divide the sum of the number of deviation, which is 5. If we divide 0.03 centimeters by 5, we will get the value of 0.006 centimeters. So, now that we have the average deviation for the two sets of measurements, let us compare these values. The ruler with the lower average deviation gives more precise measurement. Ruler 1 has the average deviation of 0.6 centimeters, while ruler 2 has the average deviation of 0.006 centimeters. Since ruler 2 has lower average deviation, then the ruler gives more precise measurements. We are now done in precision. Let us proceed to accuracy. Accuracy is the nearness of a measured value to the true value. The true value is usually the widely accepted measurement. Example, claimed by an object's manufacturer reported in the literature. One way to express accuracy in terms of absolute error or E, the capital E, shows the deviation of the measured value from the true value. Note that the absolute error can either be positive or negative, so there must be no absolute value in the formula. Take note that if the absolute error is positive, the measured value is greater than the true value. If the absolute error is negative, the measured value is less than the true value. One more useful way to express accuracy is to get the relative error. Relative error usually expressed in percent. Is the absolute error with respect to the true value? A measurement is accurate if the magnitude of percent error is close to 0. A measurement with a low accuracy is due to systematic errors. Such errors are due to repeatable mistakes on measurement, which are mainly due to instrument error. An example is a triple beam balance that is not tiered to 0 mark before used. All measurements made using the scale will carry over the same deviation of the measured mass from the true mass. Let's have another problem on dealing with accuracy. Two groups of students determined the density of water. Group 1 got a value of 0.983 grams per milliliters, while Group 2 obtained 0.979 grams of milliliters. If the true density of water is 1 gram per milliliter, which group reported the more accurate value? In dealing with the problem, let us start with calculating the percent error of the two measured values. First, for the first measurement, percent error can be compared to the true value. The difference between the first measured density, or 0.983 gram per milliliter, and the true value of 1 gram per milliliter is equal to negative 0.0117 gram per milliliter. Dividing this answer to the true value, then multiplying by 100, we get negative 1.7%. For the second measurement, the percent error can be obtained as follows. The difference between the value 0.979 gram per milliliter and the true value is 1 gram per milliliter is negative 0.021 gram per milliliter. Dividing this answer by true value, then multiplying by 100, we get negative 2.1%. Now, we compare the percent error values. For Group 1, percent error is negative 1.7%, while for Group 2, it is negative 2.1%. The more accurate measurement is the one closer to 0, since you have negative 1.7% is closer to 0 than negative 2.1. The value measured by Group 1 is more accurate. Sometimes precision is considered to determine accuracy. Given several measurements of the same quantity, the mean value can be used as the true value. This is valid if it is certain. Then there is no systematic error in the experiment. Consider the following problem as an example. Determine which of the given three measurement is the most accurate. We have the measurements 14.12 grams, 14.15 grams, and 13.97 grams. First, we get the three values as shown on the right. The mean is 14.08 grams. Next, get the absolute error of each measurement. The mean is in the problem serve as the true value, and the second column shows how the absolute errors are obtained. Lastly, get the percent error of each measurement by dividing the absolute zero by the true value, or the mean, and the third column shows the solution. So as you can see here, the absolute error is 0.04, and 0.07 grams, and negative 0.11 grams. And the percent error, so you have 0.04 grams for the absolute error, divided by the mean, 14.08 grams, is equal to 0.3% error, and so on. Now, let us compare the percent error values. The most accurate measurement must have the closest percent error to zero. In our problem, the first measurement has 0.3% error, which is closest to zero. Hence, the first measurement is the most accurate one. We can visually differentiate precision and accuracy with a set of dark pins targeting to hit the bull's eye. If all pins hit the bull's eye, it is a visual example of data with high precision and accuracy. On the other hand, hitting the pins at the same location but away from the bull's eye is an example with high precision and low accuracy. Now, if you hit the dark pins in the center in a different location near the bull's eye, then this set has low precision and high accuracy. And lastly, if you hit the pins in separated locations away from the bull's eye, it can be compared to data with low precision and low accuracy. To summarize, take note that precision is the agreement between measurement of the same quantity. On the other hand, accuracy is the nearness of a measurement to the true value. And here are references or bibliography, and thank you for watching.